Greetings, let's look at this. We have a mapping from R2 to R2, a linear map. Is defined by this. Components x and y are assigned these results in respect to x and y. And then we have a basis that's different from the domain and the codomain. The inputs are in this basis in respect to this one. Outputs are in respect to this basis. So basis B for domain, basis C for codomain. And the linear map is defined like multiplying by some matrix A from the left for the xy column vector. And this matrix happens to be exactly what the coefficients are in the prescription. 2, minus 1, 1, 3. That's exactly this matrix, the coefficients from that prescription. So that's in respect to E1, E2, the standard 1001 basis. But what we want is some base matrix that is called with this notation. And what it means is if we take some vector v as an input, some xy vector v, and its image under the linear maps in the default matrix is then expressed in respect to C, it should be equal to this matrix times the input vector v in respect to B. And the way we can construct this new matrix that takes input in one matrix in basis B and output is in basis C is constructed in the following way. It has column vectors that are simply f of the first vector of the basis B. That is, well, in general, it's each vector of basis B under the map of F, and that in respect to C. But here we only have two vectors of the basis B, so it's only two columns in this matrix that we're looking for. So it's 1, 1, and all this in respect to C, and then the second column is f of the other vector of basis B, the 1 minus 1, and that in respect to C again. So that's the point here, the whole point. So let's see what that is going to be. So all we have to do is first multiply by that default matrix A, one basis vector of the input basis B, then do it for the other one. And then after we have that, we express them both in terms of basis C, which is also simply shown here. Basis C is supposed to be these two vectors. So let's look at that. So first let's just say, let's rewrite it once again. We can still fit it on this side probably. That is, what is f of 1, 1? We multiply the matrix A by 1, 1. We put 1, 1 here. So that is going to be give 3 and 2. So we have 3, 2, and that should be expressed later in C. And the second column should be in terms of basis C. The second one is 1 minus 1, multiplying again, put into the xy here. So we have 1 and minus 4. And again, should express it in respect to C. So all we have now, these two vectors, we just have to express in respect to C and put them inside the same columns. And that will give us the matrix that we're looking for here. So let's look at that. We just put the first column in respect to C and this one in respect to C, but we remove the parentheses. We just purely put them as entries, for entries here. So 3, 2 in respect to C, what is it going to be? We can do it, I think, quite easily. So 3, 2 in respect to C. We can do 1, 2. So that's 1, 2. All right. 1 times 1, 0 plus 2 times 1, 1 gives the 3, 2. And 1 minus 4, how do we get it? In respect to C. So what do we multiply? What are the two numbers? First multiply by this first component this and the second component this to get 1 minus 4. The vector 1 minus 4 as a result. So what we can do is we can actually write it out. So it's 1, 0, 1, 1. 1 minus 4 should equal A times this plus B times this. Well, either we can try to do it, well, this would actually work out if B is minus 5, we would have a minus 4 in the second component. So we can have A times 1, 0, minus 5 times 1, 1. And then we just compensate by the A, because that only takes care of the first component. So we now have, this would be equal to A, so we now know that the second one should be minus 5. That will work out, because then we can adjust the first component. I just try to avoid doing the whole equation. It might be faster this way. One trains it a bit. So this is like this, minus plus minus 5 minus 5. And we need no, this is minus 4. So we have minus 4 minus 4. And all we need is to have a 1. So we would have A being 5. So A should be 5. So this is 5. So this is minus 4 and A should be 5. This should work out. So now we have it. And that's it. Basically, all we needed is to find a 2 by 2 matrix that instead of using the basic basis 1, 0, 0, 1 for this R2 space, we still have a mapping R2 to R2, but we have these alternative bases, B and C. The inputs are taken in B, the outputs are in C. We can rewrite that new matrix that will respect these two bases, inputs and outputs, by creating it in this form. It's going to be f of the first vector of the input basis in the first column, and then later expressed in terms of C. Second one, just multiply again by the default matrix A, so the default mapping F, the first vector of the basis B, and then later that result express it in C. Then put it in a new matrix, and it again will be a 2 by 2 matrix.